Hello guys, welcome to Placebo to Edu and my name is Vinay Kumar Nainpathani. Today we are going to learn the basics of a basic subject which is networks theory. What will be included in these basics? I'm going to cover the symbols which we use frequently in the networks theory and also what will be the direction of current through the components and Ohm's law and also the definitions of branches, nodes and loops and the most important laws those are Kirchhoff's current law and Kirchhoff's voltage law which are known as KCL and KVL. So why to waste the time? Let's get started. So the first thing I'm going to cover is symbols. Okay. The first symbol is resistor. This is the resistor. After drawing the symbol, you need to write the units of it. Okay. This is resistor. So the units is 1 ohm. This implies 1 ohm. This is how we have to read this. Okay. And the next symbol is capacitance. This is capacitance or capacitor. And here I am writing 1 mu f. Okay. So how to read this is 1 and this one is for micro and the f represents farads. 1 microfarads. Understood? Next one. Next symbol is inductor. Okay, this is inductor. Here I'm writing 1 mH. Okay, so how to read this is 1 and the m is nothing but milli, h is Henry. Understood? These are the passive elements which we are going to use in networks. And coming to the sources, we have two different types of sources. One is voltage source. This is voltage source. This can also be drawn as like this. These two are voltage sources. And the important thing you have to observe is these are DC voltage sources. Okay. After drawing the symbols, we have to write the new units, right? So I am writing here 100 V. This represents 100 volts. Okay. Next, this is a current source. Current source. Okay. Next one. This is a voltage source. These are instant polarities. AC voltage source will not have polarities, but these are instant polarities. That means for that instance, this is positive and this is negative. Instantaneous polarities. Polarities. Okay. So this is the example for AC voltage source. Okay. We have dependent voltage sources which are drawn by using diamond symbol like this. Okay, this is dependent current source and this one is dependent voltage source. I'll be explaining this while we come across these things. Okay, and the next symbol is a switch. Switch. Okay, so the arrow here represents the current direction when the switch is closed and this arrow represents the way to close the switch. Understood? So when the switch is closed, like this, the direction of current is this one. Understood? these two arrows represents how to close the switch and what will be the direction of current after closing the switch. Another thing is ground. This is ground. Only in some circuits you will be seeing this ground, but while doing the simulation you have to ground every circuit. If you don't ground the circuit, it will give us the error the circuit is not grounded. Understood? So how can you simulate the circuits? Circuit simulation can be done in LT-Spice, multisim, and so on. These two are some advanced. These two are advanced softwares which are useful for circuit simulation, and LT-Spice is very useful for the circuit simulation. So you can see those softwares if you want. After the symbols, I am ready to tell you the direction of current flow. This is very important topic, so please be concentrated. So what will be the direction of current flow? There will be two types of components in networks. That is, one is source and the other is sink. Okay. What the source will do is it gives the energy. It gives energy, and the sink will utilizes the energy. It will give the energy and the source will utilize the energy. So the even the source will have the polarities positive and negative. Even the sink also will have the polarities positive and negative. Understood? So the current will go out from the source and enter in negative polarity, and for sink the current will enter into positive and leave out from negative. Understood? Maybe this is not clear. It will be clear with a circuit diagram. For example, consider this voltage source with a resistor, and this is ground. So what I said is the current in a source will come out of positive. So the current direction will be like this. Since this is a voltage source and this is a resistor which is a sink, the current will enter the positive. So when the current is coming out like this, it will go like this and enter here. So the resistor has here positive polarity, and when the current leaves from here, the resistor will have negative polarity. And now the current goes like this and it will come like this and enters into negative. That's what I'm saying. So the polarity of resistor will depend upon the circuit. So this polarity will purely depend upon the circuit. So on the resistor there will not be any positive and negative signs, but when a resistor is placed in the circuit it will get the positive and negative signs. So we can open this and we can connect the same terminals, like for example this is A and B. We can also connect it as B and A since it won't have any polarities, but once it is placed in the circuit it will get the polarities like A is positive and B is negative. That is because of the current flow direction. I think you understood. And the next concept is Ohm's law. Ohm's law. Ohm's law states that at constant temperature and all parameters are constant, all parameters of conductor constant, then voltage is directly proportional to current through a conductor. So after considering this proportionality constant, I can write it as Ri. Okay. This is the Ohm's law. Ohm's law states that at constant temperature and all parameters of the conductor should be constant. Parameters of the conductance means length, cross section area, all such types of parameters should be constant. Then the voltage applied to the conductor will be directly proportional to the current through a conductor. Okay. So from that we get V equals to Ri. This gives the relation of voltage and current of a resistor. Okay. So Ohm's law gives the relation between voltage and current of a resistor, and we have the voltage and current relations for capacitor, inductor, and that I will be explaining in upcoming videos. Okay. So this is the Ohm's law. After this, I have to explain you the power. Power is nothing but V into I. This one is very important thing. Power is nothing but V into I. Okay. From Ohm's law, we have V is equals to Ri. So power I can write it as Ri into I, right? So power is equals to I square R. Whenever I know the current and resistance, I can find the power consumed by the resistor. Okay. What if I don't know the current? I don't know this value. So what I have to do is I will consider I is equals to V by R. So here I am assuming I know this. So when I is equals to V by R, then P is equals to V into V by R. Therefore P is equals to V square by R. So whenever I know the voltage, I will get the power. Okay. I think you got the relation between power, voltage, and so from Ohm's law I can say that power is equals to V into I, which is equals to I square R, which is equals to V square by R. Understood? This is an important relation. After Ohm's law, our point of interest is branches, nodes, and loops. This one. For example, consider a circuit like this. Branches is nothing but if it has one element, then it will be one branch. See here, it has one element, that is the voltage source. So this is one branch. It has resistance, so this is another branch, and this has another resistance, so this is another branch. This has another resistance, this is another branch, and this is another. So in this circuit we have 5 branches. Understood? If there is one element, then it is considered as a branch. Here I have another branch with 2 resistors. Okay. Now the number of branches will be like that. Here I have to count these branches also. What I told branch means if it has a component, then it should be considered as branch. So here we have resistance, so this is branch 1. So branch 6. Here we have 2 resistance, so this one should be considered as 2 branches. So this one 7 and this one 8. So the total number of branches here is 8. Understood? Now coming to the nodes. Nodes is a junction where 2 or more branches are connected. Okay, so consider here two or more branches are connected. So this is a node 1, this is node 2. Let me, this node 1, node 2, and here is node 3, this is node 4, and see here two branches are connected. So this one also a node, let it be 5, this one node 6. Here it is not a branch, it's a conductor and it's not a branch, so it can be a reference node, so let it be. Okay, now these two are connected with a conductor. This is a conductor. That means this one, this one, this one, this one, these all will constitute only one node. I think you understood. So number 6, number 4, all these nodes constitute only one node. So wherever there is a conductor, we won't consider it as a branch. So these all nodes will touch at one point. So I mean these all branches, number 1, number 3, number 5 and number 8 branches will touch at one point, and that is here, let it be, and that will be considered as a node. So let it be 1, 3, and this one is fourth node and this one will be the fifth node. So there are 5 nodes here. Understood? The junction where two or more branches are connected is known as node. We have two different types of nodes. One is simple node and another one is principal node. Whenever there is a junction of two branches, then it will be a simple node, and if there are 3 or more branches connected to a junction, then it will be a principal node. See here, we have one, we have this one. I think it's a bit confusing here. I will draw here for better explanation. I'm numbering the nodes. This is 1 since 2 branches are connected. This is 2 since 3 branches are connected. And this is 3 since 2 branches are connected. And this one is also node since 2 branches are connected. And this one, this one, this one. All 3 will be constitute a single node, which is number 5. Now I have to find the simple nodes. Simple nodes is that in which only 2 branches are connected. So here 1 and this one and this will be the simple node. And see here 3 branches are connected, so this is not a simple node. And see here 2 branches are connected, so number 4 will be simple node. What are the principal nodes? Wherever 3 or more branches. So this one, this one, this one, 3 branches, so number 2 is principal node. And here I forgot to tell you that this one and this one only 2 branches are connected, so 3 is a simple node, 4 is a simple node, whereas 5 is the principal node, since this one, this one, this one, 3 branches are connected. Therefore here simple nodes are 1, 3, 4 and principal nodes are 2, 5. I think you understood. Okay, now coming to the loops. Loops are nothing but a closed group of branches. See, here is a loop, here is a loop, and another loop is this one. This one is another loop that you should not forget. Okay, the loops are, it should be closed, whatever may be the branch inside, but if there is a closed loop, then it will be a, if there is a closed group of branches, then it will be a loop. For example, like this. Okay, so here we have this one as one loop, this one as one loop, and the whole thing is a loop. Okay, so we have 3 loops here. The same thing I drawn in another topology. So here we have 3 loops. I think you understood the definition of branches, loops and nodes. So how can we use these branches, nodes and loops? I gave you the definitions and how we can find the branches, loops and nodes, because to explain you the KCL and KVL. Okay, KCL is purely depend on nodes, whereas the KVL will purely depends upon the loops. Okay, so what is KCL? KCL is nothing but Kirchhoff's current law, and whereas KVL is nothing but Kirchhoff's voltage law. Okay, before going to KVL, I am discussing the KCL. For example, consider a node here. This is a node. For better understanding, I am drawing this much size. This is a node. We have three branches like this. Okay, from the branch 1, the current is I1, which is passing to the node, and the current is I2, which is passing away from the node, and the current is I3. Whenever there is a condition like this, what Kirchhoff's current law says that the arithmetic sum is 0. Arithmetic sum implies I1 minus I2 minus I3 is 0. What he's saying that the current coming to the node will be equal to the sum of currents leaving the node. So if there is a water pipe here, the water is coming like this, then the water will be distributed based upon the pipes, how many pipes, the outlet pipes are there. The same thing he said in the form of currents. So the water coming, that is the current coming to the node is I1, and the water is distributed as I2 and I3. This is the Kirchhoff's current law. Okay, if you do the problems, it will be very clear. The next one, Kirchhoff's voltage law. For Kirchhoff's voltage law, I am going to consider a circuit like this. Let it be a circuit, and the voltage across this one will be V1, and the voltage across this one will be V2, and the voltage across this one will be V3, and here the voltage is V. The arithmetic sum of all the voltages in a loop is 0. The arithmetic sum of all the voltages. While applying KVL, the important thing is we will consider it as negative when we jump from positive to negative. Okay, we will consider it as positive when we jump from negative to positive. Understood? That means what I'm saying is when there is a hike in potential, means negative potential to positive potential, I'm going to consider it as positive. When there is a decrease in potential, that is from positive to negative, I'm considering that potential as negative. And some of the people will consider it as in reverse, that is when going from positive to negative, they will consider as negative. But here, since it is increasing, I'm considering it as positive. Okay, so now how to add these voltages, which means how to do the arithmetic sum of these voltages. For that, I am considering a current in the direction like this, I and I. Okay, so now the arithmetic sum of the voltages I have to take. For starting, I'm going in this direction. Okay, so what I told, whenever we go from negative to positive, the voltage should be positive. So I am touching the negative first and going to positive. So I am jumping from negative to positive. So the voltage will be positive. And the next one, I am going from positive to negative. I am jumping from positive to negative. So here the voltage should be negative. So minus V1. And again here I am jumping from positive to negative. Again the voltage should be minus V2. And the same with V3. So this is the arithmetic sum of the voltages. Therefore V is equals to V1 plus V2 plus V3. This is what the KVL is. Hope you guys liked this video. Please like, share, comment and subscribe for more videos. If you guys didn't like this video, please let me know in the comments what are the improvements should be done. Thank you.